machine itself, very fast, and you can see that from before this we go to micro, okay, then nano, and now we go to the pico itself.
Thank you, Prof. But I think this is another last question here. What is your opinion about the market of PhD holder in industry or academic sector for upcoming years? Is it the demand for expertise in related field will significantly increase?
Of course. Okay, for this question, actually, of course, in higher education, we go for the problem solving. We want to get the problem solver. So normally, for PhD, they have a project that they need to solve project problem. So we can see that in management team, okay, we need PhD holder. Because of what? Because manager must try to solve the problem. Okay, so PhD level have very matured that can solve the problem, and in future we deal with the skilled worker. That this skilled worker will deal with the machine, will deal with the technology that can solve immediate. We need the immediate action or immediate problem solver. So coming soon, if you can see that other, for example, in Russia, in Germany, most of the skilled worker is PhD holder. So slowly, Malaysia will go to that level. Okay? That's why we can see that before this, Malaysia target about 60,000. If I'm not mistaken, 60,000 PhD holder to go for the industry in future.
Thank you so much, Prof. So hopefully you all gain something from this session. Thank you, Prof. So next, I will invite our second keynote speaker that will be led by Associate Professor IR Dr. Hafizi. Thank you.
Thank you to Professor Datin Sakinah and Dr. Nur Azrani for their valuable contributions. For the second keynote speaker, we will rest for 2 minutes.
Okay.
Saya dah tak teman ya.
Nah.
Assalamualaikum warahmatullahi wabarakatuh. Now we are continue for the second keynote stage. So I would like to invite Dr. Muhammad Hafizuddin Zohari as a moderator to kindly present the guest speaker. Please welcome Dr. Muhammad Hafizuddin Zohari.
Assalamualaikum warahmatullahi wabarakatuh and good morning. Wassalamualaikum warahmatullahi wabarakatuh. Thanks to Ms. Chairperson, thanks to our Honorable Dean, Prof. Dr. Mahadzir, Ishak, Dean of Faculty of Mechanical and Automotive Engineering Technology. Thanks to our previous first keynote speaker, Datin Ts Dr. Sakinah, Binti Abdul Munaim, for the very speech. And now I would like to introduce our second keynote speakers, IRTS Ikhwan, Yusoff, a professional engineer from IEM. IRTS Ikhwan has started his professional career since 2004 in various positions, mainly in project engineering. His specific area of expertise focused on floating liquefaction natural gas, FLNG, and oil and gas floating facilities. He started his career with MISC Berhad as a management trainee. With a bachelor's degree in electrical measuring in power, his role was to focus on various floating gas terminal project development. For example, FLNG, FSRU, FGTL, and FCNG. IR Ikhwan later joined a Norwegian oil and gas consulting company, BW Offshore, as an interface manager, special projects. He was assigned to lead a detailed feasibility study for an FLNG project in Malaysia. Besides, he was also worked as a business development manager, where he proposed solutions for oil and gas development using floating facilities. He later joins the national oil company PETRONAS as a project engineer. He was involved in the PETRONAS Floating LNG1, FPF-LNG1, front-end engineering design, FTED project, where he was based in Paris, France, for about 1 year. Upon completion, he was then assigned to Yokohama, Japan, to execute the PETRONAS Floating LNG2, LNG2 FTED project. Besides, he works on both projects in Kuala Lumpur as senior project engineer in charge on overall project management activities, including regulatory requirements and stakeholder management. In 2017, he was certified as a technical professional in front-end engineering department, resides under PETRONAS Group Technical Solutions, GTS. After 3 years, he was transferred to Malaysia Petroleum Management, MPM, department, overlooking resource and development, focusing on Sarawak oil and gas field. Until now, he continued enhancing his skills in front-end engineering by conducting evaluation on oil and gas facilities, design and engineering proposed by the asset owners. With his vast experience in industry, I myself can't wait to hear his presentation. Without further ado, I will leave the floor to our keynote speaker, IRTS Ikhwan, Yusoff, for his keynote speech. Tafadhal.
Thank you very much, Dr. Hafizi, for a very lengthy introduction. I just would like to check, can you see the slide now?
Yes.
Okay, first of all, I would like to say thank you so much to the organizing committee for inviting the industry players to share our knowledge, expertise, and experience in this International Postgraduate Conference on Mechanical Engineering. So I am so proud to share our lesson learned, our experience, our know-how in this engineering marvel in oil and gas industry specific to the floating LNG, the world first. So then of my presentation today, so I will try to go as layman as possible because there are a lot of technical jargon, technical details in this presentation. So please bear with me and please prepare with your possible question for me to answer towards the end of the presentation. So first of all, I would like to start with the project development background, how we PETRONAS started with the project, and some overview of the business opportunity, the definition of the LNG itself, what is liquefied natural gas, and how do we really transport the natural gas nowadays and moving forward in the future. So the debate between having a facility onshore versus offshore, how we initiate the project, and the conceptual design consideration throughout the evaluation and the study of this development. on how we construct this facility, this mega structure, I would say. The key design parameters and technology, I will also highlight a little bit on the technology application. What are the advantages, challenges in developing this floating solution? Some case study focusing on the technology screening, as well as I will conclude this presentation towards the end. So if you notice, there are a lot of F word stands for floating actually. So my expertise in the company is actually on floating facility, which actually floats on water, you know. So some background of this development is actually we have started this back in 2006, where PETRONAS has considered many options to monetize the small and stranded gas field. So as we understand, these fields are very, very far, located very far from shore, very far from existing facility, very far from existing pipeline network, and etc. So from that development option, we have studied various options. For example, we have looked at the small-scale LNG plant, floating gas to liquids, natural gas hydrates, as well as floating CNG, compressed natural gas. Don't worry, I will go into more detail later what is meant by CNG and GTL. Yeah. So as a business opportunity in general, we are looking at a certain number of fields, yeah, certain field size for us to make use of this facility in extracting the reserve underneath the earth, for example, on how we extract the gas out of the earth. Okay. So again, let me define what is stranded. So by definition, stranded means the resource which may be too remote or far from market of natural gas, where construction of pipeline is a bit expensive due to the fact that you have a very bad condition for seabed as well as water depth, which is very deep. So again, how far is far? So in the case of PETRONAS floating LNG, PFLNG, I think it is fair to define that it's more than 150 kilometers from shoreline as far. And again, how deep is deep? So in our case, the way we define deep is actually more than 200 meters of water depth. So again, as I promised, what is CNG, GTL, and LNG? So liquefied natural gas is actually stored at approximately minus 160 degrees Celsius. Yeah, it's a sub-zero temperature. And how is it different from natural gas? So LNG is actually compressed about 600 times of natural gas. GTL is about 1400, while CNG is about 200. So that is the high-level ratio on the definition of the compression of those elements. Yeah. So the transportation mode for natural gas. So originally, this is the way we pipe the natural gas. But again, when we pipe the natural gas, it will depend on the distance, how far that we want to transport the product. And again, this is very, very traditional way. It can be either onshore and offshore. And we have some concern when it comes to remote area. So this is why we move from pipeline to ship shape. So by having this facility on a ship shape, we will have to design as relocatable. So as you can see, how do we differentiate between onshore and offshore? First of all, we look at the dollar and cents, the capex point of view. So from capex, we believe that one facility at one single location will basically optimize the cost. From permitting, by having the facility located offshore, it is going to be simpler and easier in terms of process of obtaining the permitting. In terms of the installation, for onshore, we will have a permanent installation, but we will have a relocatable floating unit if we are building based on a ship shape. In terms of the location, it is going to be very open and easy if we are building on offshore. So what we are saying is actually by having this floating production storage, we are utilizing a proven key component. For example, on the left-hand side, you can see the process plant. This is very, very typical. We have 100,000 of them being built everywhere in the world, as well as the loading arm, the way we transfer the product into the tanker, the containment system itself, as well as the turret. Turret is actually a component to allow the vessel to rotate. Okay, so what we are saying is actually this is a marvel solution with a combination of proven components. So what is really a floating LNG? Okay, as you can see on from your left-hand side, we started with gas production, then we have offshore pipeline, we have a liquefaction plant, we have storage and offloading, and then we have shipping. Finally, we have storage and regasification. Those are the traditional way of producing the LNG. But now, when having this floating LNG, is going to be an integrated system, a floating production, storage, and offloading in one single unit. So this facility will be located somewhere in offshore, close to the field, to extract the natural gas. Okay, it will also produce the LNG at the same location. So this is where the offshore configuration looks like. It can be either as number 1 or number 2. Number 1 will represent when the facility is connected to a central processing platform. So this is where you can connect the facility to the existing. But if you look at number 2, it's actually full well stream. Full well stream meaning you are extracting directly from the reservoir, from the gas well. So those are the possible configuration that we develop this floating LNG and having to suit the field characteristic as I mentioned earlier. So in general, the facility is having about 22 modules. So I noticed you have a few topics of interest like energy, manufacturing. So I would say this is very much related to material and also marine engineering or even structural engineering, because they involve a very, very detailed and thorough study and calculation with regards to the weight. Because the more equipment you are putting, the heavier the equipment will be, and the bigger the ship you have to build or design. So everybody knows about Twin Towers. So this is how we physically compare the facility between the Twin Towers. As you can see now, PETRONAS has already built 2 units of this floating LNG. The first one is actually about, if you were to put vertically, it will reach up to level 75 of our Twin Tower. The second one, we have built slightly bigger, which can reach up to level 80 of our Twin Tower. Okay, I will go through in very detail later on what is the biggest difference of this facility between each of them. So these are the key design parameters. As you can see, the biggest difference is actually the first one was designed to go to shallow water, whilst the second one is designed to go for deep water. As I explained earlier, deep water means maybe more than 1,000 meters of water depth to extract the natural gas from the well or reservoir. So in terms of size, it's slightly bigger for the second one, as well as you can see the increment with regards to the tonnage and also the processing facility on how we process the natural gas into the end product. As far as distance to shore is concerned, we are talking about 180 to 200 kilometers. Okay, so this is the process that maybe most of you will appreciate on how we go through the engineering design processes. We started with conceptual design. We cannot run away from this. How are we going to shape this? How are we going to choose the processing equipment? How are we going to choose the cargo containment system? How are we going to transfer the product, you know, which is stored at minus 160 degree. It's a sub-zero temperature. How are we going to moor the facility? How are we going to sure this facility is going to be operated ideally and safely. That is the most important. And of course, in front-end engineering, where I am located, is basically we were developing the project specification to see how we are going to design the facility. So this is on the construction itself. So how we started to build the facility. So first we started with steel cutting. It's a piece of, I would say, iron, steel. We cut it and we shape it into a component fabrication before we pre-outfitting, involving a lot of welding, a lot of people and hours before we go to block painting. So after that, we will go to pre-erection and super block outfitting, and then keel laying. And when we assemble, you just imagine like a Lego. We assemble this like a Lego until we reach and achieve a shape that we desire. So those are on the hull portion. Now, this is on the top side portion. It's all the same. We started with steel cutting, and then we go to assembly, pre-outfitting, painting, then we turn over, outfitting, model outfitting, ready for lifting, meaning all the equipments to process the resources is lifted on board the facility. So you can see the duration of each activity is taking quite some time. For your information, we constructed this in Korea, one of the islands in Korea. So their main function is to build ship. So this is actually their typical activity over there. So what are the key design criteria in developing this floating facility? Of course, like I mentioned, we cannot run away from safety. Safety is of paramount. So we put the safety on the top of our priority. So production capacity and field development strategy, as I mentioned, we go to shallow water with the design limitation that we have. And we have to design to be more robust if we want to go to deeper water. So other than that will be on, there are a lot of research and development on marinization because we are using a lot of equipment to be brought to offshore environment. So this is the key technology selection that we are talking about. So we have installed this is called turret, yeah, T-U-R-R-E-T, and this is, the function is to anchor the facility at site location, because remember, we don't have any structure. It's a floating facility, so we need this to basically anchor our floating system. And third one is on the cargo containment system. Like I mentioned, the place where we store the product. And last but not least, on how we transfer the product into another facility. So what are the advantages of this floating facility? First, of course, it's a very small and accessible to stranded gas field. So those field that is very far, is very difficult for us to build the jacket or the platform. This is where we are going to go. So what we are saying is actually it will contribute to faster overall project schedule as well as having early production system. And again, more importantly, this is very mobile and it is relocatable. You just imagine if we are building the platform, we cannot relocate. But having this as ship shape, we can tow the ship to a new location. If we, in the situation we found a new gas or resources, we will go to the next location. And last but not least, we also support the greenhouse gas emission by not flaring or venting the gas unnecessarily. So yes, we do face a lot of challenges in building this plant due to the fact that this is first of its kind in the world. We have limited track record, we have no reference, we have no benchmark, but we took bold decision to build this together under Malaysian flag. And of course, like I mentioned, the marinization of topside equipment. Again, due to the fact that we are constructing in Korea, we are subjected to typhoon and cyclone, so we have to plan the project carefully on when to tow back to Malaysia. So as for the conclusion, we believe floating liquefaction natural gas is a breakthrough technology and is an industry game changer. Of course, it requires bold decision for us to become the pioneer, especially becoming the first company to build and operate this facility. Yeah, and we believe FLNG signifies technology advancement because we are using a lot of new equipment, new product in this facility. Will add value to the stranded and gas resources. So we are proud to say that PETRONAS will become a reference or become a benchmark for future projects. And of course, we are taking all aspect of risk before we even operated this facility. So by that, I would like to say thank you for your kind attention. I hope that you can appreciate the content of my presentation. Thank you so much.
Thank you, IR Ikhwan, for a very interesting and informative presentation. I believe all of us have benefited a lot from the speech. For your info, the documentary of the PFLNG1 already available in YouTube. You can have a look. And PBT also have done some documentary about this. And then this is our great opportunity to hear firsthand from the engineers involved with this manufacturing of the PFLNG. So I would like to open for the floor online, and then also here in the room to ask a question. I can see also here in the room we have Prof. Dr. Adam, and then also we have here is Professor Nick Abdul available in the online. So I would like to open for the question. All right, so we have a question. I'll start with one from Muhammad Anafi. The world's first completed FLNG production facility is fully owned by PETRONAS. What is the key factor bring PETRONAS to succeed with the project?
Thank you very much for the interesting question. This is very good question, Encik Muhammad Anafi. So yes, we were the first. To share with you, Shell has started this first, but they took so long to mature the project. So what is the key factor to bring PETRONAS to be successful in this? Only one thing. You have to believe in technology. I repeat, you have to believe in technology. Because technology is something very new, where you need to be creative and innovative. So if you yourself do not believe on new invention, you will not be successful in this. So with no reference, no track record, we have to trust the maker of the equipment. We have to understand the operation philosophy, I would say, as the operator of the first facility in the world. So that is the key.
Okay. Thank you. Prof, do you have anything to say?
Okay. Very nice presentation. And if you look, this is the first project from PETRONAS that related to the FLNG, and I think there is a lot of things, experience, and also learning that Malaysian can learn from this project. So for further on, how we can educate our young, like our students, that can go this kind of like advanced technology, such as this kind of project.
Thank you, Prof, for the question. First of all, it's all about sacrifice. So, you know, besides being very proud of, being involved in this marvel or mega structure project, among few Malaysian, the sacrifice is there, For example, I take example of myself. I have families. I have left the family, small kids, even baby, for a few years, for 3-4 years, to be located at consultant office. In that sense, As per introduction, I was based in France, I was based in Japan, I was based in Korea. So first is the sacrifice, you know. Beside all the success story that you achieve, there is somebody who really sacrificed for you. And again, make use of the knowledge that you have gained throughout the study time, school time or university's time, because some of the theory is going to be applied. And for students, I would encourage as soon as possible when you finish your study, please register yourself to be a registered professional engineer and go all out. So in fact, myself, I took my professional engineer a bit late after the completion of the project. But again, this project helps me a lot. I make use of the project to make our professional engineer report, and I was successful.
All right, thank you. Okay, so we have more coming questions from Munaim, I think one of our PhD students here. May I know who's the mastermind behind this PETRONAS FLNG? Is it local engineer, brain? Is it local engineer brain or foreigner?
Thank you so much, Hilmi. Very good question. I am so proud to tell you that we are all local people who came up with this idea. But again, it's not as easy as you think. We have developed this for the last close to 15 years. And remember, our competitor Shell, they have been working for the last 20 or 30 years. So to have this in mind, to believe in the technology is going to work, require a very bold decision and require a combination of good knowledge, I would say. And to directly answer to you, we are all local people. Yes.
All right. I have more questions from Muhammad Shukur. What are the main challenges? I believe these are most challenges in the development. Human resource, engineering, cost, timeline.
Okay, in project management, yeah, in general, engineering, cost, timeline is the key. These three items is most often being updated, reported on daily basis. So you just imagine we were working outside of Malaysia with a time different, with the language barrier, for example. We were talking to French, we were talking to Korean, we were talking to Japanese. Even we have multi-national people who have their own function in this project. So the key challenges on top of what you have listed here would be on the interface, because we need to deal with different people, different background, different knowledge, and different expertise. Yes.
All right. So I think Prof. Nick Abdullah have a question. Can I leave it to you, Prof?
Okay, thank you. Assalamualaikum, IR1 Ikhwan. Very interesting and very encouraging and spirit uprising speech talk about this success story of your team and PETRONAS altogether. I believe, as you said, one of the factors of the success is your belief in technology. And then secondly, I think also ready to sacrifice. But I think one of the other factor is, of course, the endurance of your team member to maintain the teamwork. I think that is because it takes quite a long time compared to the shell or whatever. Maybe your team is much more committed to this project, not only for the, I mean, in terms of really technology and so on, but your teamwork. Could you explain us a little bit how you manage your people to focus to this project with a lot of challenges and everything? Thank you.
Okay, thank you, Prof. If I were to explain this I would say because last time, back in the days, we were basically running or chasing to be the first in the world. You know, within split second, you can be the second, you see? So we know for the fact that our direct competitor, which is Shell at that time, was also doing something, you see? So everybody was in a very secretive mode, I would say. You know, everybody don't want to reveal what is the current status on what they are doing, you know. But again, one of the biggest lessons learned is actually for us to do something which is within our capability and capacity. So we understand that Shell is building too big, beyond the capacity of even the shipyard itself, you know. So you just imagine one shipyard, for example, you have, okay, the closest analogy will be you have a car garage at your house, just enough to accommodate Pro 2, I would say. But again, you try to bring in MPV inside the garage. So this is something similar analogy that we are using to the shipyard. They are building a very huge floating LNG where the shipyard itself cannot accommodate as far as the length and the width is concerned. So what we do in PETRONAS is basically to play around with a comfortable size of ship for the shipyard itself to be comfortable in building it. So that is the recipe of the success. You see, for you to go big, for you to be famous, sometimes you need to be very medium term rather than going wow factor immediately. So you just imagine now, I mean, Shell only have one unit and they are still struggling to operate it. And we, PETRONAS, building at a smaller scale, we have 2 units already. Yeah.
Right. So,
okay, thank you.
All right, Prof. So we have another question from Dr. Nasrul. How we as academic researcher from university can contribute to this project in the future?
Okay. As far as industry is concerned, yes, we are very much open. We look forward to new suggestions. For example, I mentioned to you, we are dealing with a very heavy equipment, for example. So maybe some significant contribution from mechanical student, for example, on how we design the equipment to be more lighter, for example, to be lighter but bringing similar function or more efficient function, for example. So this is something that I can think of. And maybe from the area of process engineering, for example, how do we design something which is safer to environment, which is more friendly to the environment, releasing less hydrocarbon to the environment, releasing less carbon to the environment. So this is something that you may contribute in the future, yeah? Because I believe every country is going towards greener future, yeah?
All right, thank you very much. I think you have any other questions more in the room? So,
sorry, Dr. Mahadzir. Just one question. Technical.
yeah, Prof. Silakan, Prof.
Yeah, technical. I just want to ask about the specification. There are 2 types of operation. One is of this FLNG. One is the direct extract the oil from the seabed, and the other one is from the other available platform. And I just want to ask you, what are the conditions? Is there any restriction of this operation? I mean, in terms of the weather and in terms of the wave and some type of wave and type of something related to weather. How is this system accommodate this situation?
Thank you very much, Prof. Very interesting question. This is my favorite question, in fact. We have gone through a tremendous study in marine engineering and how we're going to withstand the weather, especially. especially when we are operating in Sabah and Sarawak area, which is very prone to the I would say monsoon, if it's not typhoon or cyclone. So you see, we were collecting up to 20 years Met Ocean data. You see, this Met Ocean data is giving the trend on what is the highest wave height, HS, in this case. So the limitation is always there. For example, during the transfer of product between the facility into product tanker, the limitation of battery envelope is only 2.5 meter of wave height. So how do we come up with that? We went through the meteorological database. We found that 90% of the year, we will be operating within 2.5 meter of wave height. So this is how we design the facility to withstand that number. But in normal operational condition, not including transfer, we are good to operate at 4 to 5 meter wave height. And to answer you on whether we connect to existing platform or we go independently, you see, if we have extra resources, extra gas which we can produce, but we are not having sufficient ullage in the existing facilities. So this is where we go and park our facility close to the production platform and extract or tap from the existing pipeline to allow the extra ullage coming to us. You see? So in the event that there are no facility, we can go there and extract straight away from the reservoir.
Meaning that you have also a mitigation measure in case of the level, the height of wave is above 2.5. So in that case, which is quite seldom, isn't it?
Precisely. Although it's very seldom, but we have mitigation towards that in terms of design. For example, we have QCDC, quick release system. So should the wave go beyond 2.5, it will automatically decouple. So this is where both our facility will casted away from each other. Because you just imagine this floating LNG is like a floating bomb. So with the single small spark, it will detonate the whole platform, the whole facility, you see.
Thank you.
Yep. So we're still opening for questions. If there's no questions, then I believe this is the end of our session. First, I would like to thank Ikhwan for the opportunity come to our conference, giving a very nice speech, telling a lot of very interesting knowledge to us, and then the involvement of the audience to ask the questions. Then I would like thanks to all, and also to the dean. And then I think that's it for now. I think with that I leave it to the chairperson for the closing.
Thank you to IRTS Wan Muhammad Ikhwan, Wan Yusoff, and Dr. Hafizi for the meaningful presentations. Before we end the opening ceremony, I would like to request from our audience to switch on your camera. We will take a picture together with our guests for a memorable viewing. So I hope from all our audience to switch on your camera.
Ramai.
Alright.
Okay. Dah ambil belum?
Oh, Prof ada.
Mana ada?
Ada.
Say cheese.
Okay, say hi everybody.
Hi. Okay. Alright. Okay.
Alright.
Okay.
Thank you everyone.
Ishak.
Okay. Ladies and gentlemen, may I thank you for your active partaking in this program. I hope you enjoy this program. That's all for this morning, and we will proceed to the parallel session at 10:45 p.m. Thank you and enjoy the conference.
Saya tunjuk hasil depan pemakan yang kita dengan mengujak. Tapi kena buat tak ya tu? Ramai kan? Jauh-jauh. Sebab saya ambil gambar ni saja tu. Cara orang petang tu. Boleh ni, tutup kursi. Boleh kan? Wire. Siapa yang biru?